In 2003, the 2,000-year-old city of Cologne, located in the southern region of Germany, embarked on a metro line construction project. The north to south metro line was to link the southern part of central Cologne to the urban railway network via a direct line. This made much more sense considering that at the time there were only bus routes which had to pass through narrow winding streets in the historical city center, which presented a completely inadequate public transportation service. The €650 million project was planned to be finished in 2011 after a period of 8 years of tunnel construction, finishing the stations and equipping the running tunnels with all the technical installations before the new line opens. By the summer of 2008, the construction of the running metro tunnels had been completed. What was left was the construction of stations, 2 emergency shafts, and an underground turnoff, which were to be constructed by special methodologies, applying partly cut and cover, a construction method that involves digging up a trench, constructing a tunnel or a metro station, and then restoring the surface. On the other hand, applying mining methods in combination of ground freezing techniques, a construction method that I touched on in one of my previous videos. It was at this late stage of construction when disaster struck.
Sometimes in big construction, engineers must not only focus on their own structure, but everything else around them. Get it wrong, and the results can be catastrophic.
You see, a catastrophic accident happened in the early afternoon on the 3rd of March 2009 during the final excavation work of an open pit shaft at Weidmarkt turnoff. The ground around the excavation caved in, leading to the collapse of a 7-story historical archive and an adjacent residential building, killing 2 individuals.
This catastrophe happened in the blink of an eye.
The historical archive hosted 33 kilometers of shelves containing numerous original documents dating back as far as the 19th century. There were even original battle commands written by Napoleon Bonaparte himself and some artifacts from the Roman Empire.
This collection was unique. The documents were irreplaceable. They provided a window not just into Cologne's history, but the whole of Europe's past.
So, what happened? What were the causes that led to the collapse that almost destroyed the entire history of Europe? My name is Chido Chashe. I'm a geotechnical engineer, and you are watching Geotechs with Clemens. The construction of inner urban tunnel facilities has a large number of different marginal conditions to take into account during development and the design phase. We have the basic static constructional, technical, hydrological, and soil mechanical marginal conditions at the pre-planning stage that often require innovative solutions to accomplish. As a geotechnical engineer, I am more interested in understanding geological formation and materials, the subsurface structures, and how they will interact with each other. You see, soil tends to behave differently when subjected to stresses. This can be in the form of loading, like supporting a building or a bridge foundation, and unloading due to the removal of materials during excavations or tunneling. In the case of the Cologne North to South project, the soil was subjected to both load conditions. Because of the proximity to the Rhine River, the north to south metro tunnels are located in the water-bearing quaternary alluvial deposits consisting of sands, gravelly sands, and gravels. This is consistent with the materials found along river floodplains. You see, flooded rivers carry more water during rainy seasons, increasing the material carrying capacity. In turn, when the flood levels recede, the materials are deposited along the river floodplain. And this process happens over and over and over again for an extended period, creating a geological unit of alluvial deposits. As we all know, ancient human settlements have always been built close to water sources, as in the case of Cologne, to access water for domestic use and agriculture. Furthermore, for transportation purposes, as water transportation is one of the earliest modes of transportation. In these kind of geological conditions of water-bearing granular materials, mechanical tunneling is the preferred method. The two parallel single-track running tunnels of the southern section with an internal diameter of 7.3 meters were continuously driven by a tunnel boring machine, or TBMs. A TBM is an impressive piece of machinery, more like a mobile production factory line capable of excavating soil and rock with the leading cutter head, disposing of spoil materials via conveyor belts, and installing concrete segment linings, leaving a smooth open tunnel behind. The construction of the tunnels were completed in the summer of 2008, and the project proceeded to the next phase, which was construction of the underground stations and special structures. As I mentioned in my introduction, it was at this point of the project when the collapse happened. On the day of the accident, the circumferential diaphragm walls of the Weidmark pit were completely finalized, penetrating 5 meters into the less permeable tertiary ground formations underlying the sandy gravelly cover layers. The final depth reached about 45 meters below the ground surface. The excavation works inside the shaft had nearly reached the final plant level of 28 meters below the surface. During the construction phase, groundwater was being continuously pumped up to lower and control the water table inside the shaft to enable the works. Now, it is not clear what went wrong from a technical and constructional perspective that led to the collapse. I spent months on end researching for this video and scouring the internet for some technical documents on the cause of the collapse, and all I could find were news articles covering the legal battle that ensued in the aftermath. This is unusual because usually when such a disaster happens, academia steps in and technical papers are published. But anyway, I managed to find a paper published in 2009 before neither the technical nor the first juridical investigations were finalized. The paper presented two possible reasons that could have led to the collapse based on initial assumptions. There were no visible failures on the diaphragm wall. Therefore, the failure could have occurred below the excavated level of the shaft. For example, a large hole or severe honeycomb or a weak joint between two neighboring wall sections. This can happen due to improper concrete quality, that is, concrete consistency or incorrect aggregate grading, and concrete placement challenges like the method or the technique used during concrete pouring. A hydraulic ground seepage could also be the reasons for the accidents. You see, according to eyewitnesses, about 10 to 15 minutes before the collapse of the historical archive, an increase in rush of water and later up to 5,500 cubic meters of ground materials had started. This information supports both theories. If there was a breach on the diaphragm wall, because of the head difference between the groundwater level and the location of the breach, the pressure gradient could have forced water into the excavated pit, carrying soil materials in the process called piping. The same explanation holds for the hydraulic ground seepage theory, with the only difference being the water rose from the bottom of the diaphragm walls. This is possible if the design engineers underestimated the permeability of the tertiary geological unit into which the wall penetrated. The accelerated water and soil infiltration into the Weidmark shaft caused a significant loss of ground underneath the archive. This resulted in a cone-shaped sinkhole in which the archive and the residential building collapsed in. Accidents of this nature don't happen that often when it comes to underground tunneling. From a technical point of view, tunneling can be regarded as being very safe as long as skilled planning and execution is applied. You know, in geotechnical engineering, we spend a lot of time and resources towards risk mitigation and implementing redundancies. This is proven by statistics of many successful finalized projects of hundreds of kilometers of metro lines and underground substations across the world. However, in the unfortunate event that an accident happens, it leads to tremendous financial losses and precious life. The north to south metro collapse led to 2 fatalities and damages of more than 1 billion euros.
At a district court in Cologne, it was ruled that the collapse was caused by an error in the construction of the diaphragm wall, and that this error was solely to blame.
This has been Geology, and you've been watching Geotechs with Clemens. Please leave a like and subscribe to the channel if you enjoyed the content. See you on the next one.